This is the solution video for question 17 from section B of the 4th sample test for CSAT. In this question, we're told a below diagram shows a trace on a 4x4 grid with visiting every point exactly once. We're asked to consider the same type of trace on an n by n grid where n is some arbitrarily large number. Given this, we're told that the sum of 1 over k from k equals 1 to infinity diverges to infinity. And we're told using this, show the sum of all acute angles of the trace also diverges to infinity when n, which is the grid size, tends to infinity. The easiest way to do this question is being careful with what it actually asks you to do. Because our instinct is to try and come up with a formula for a general n to tell us what the sum of all the internal angles are, and then write it down and go, look, this diverges as n tends to infinity. But the thing is, that's going to be quite hard for me to come up with. There's a lot of angles to add up. There's a lot of things you've got to double check that you've not double counted, etc. It might be different if n's even or odd, etc. There's a lot of things to worry about. But the thing is, we just have to show that it diverges. So if we can just add some of the angles up and show that diverges as n tends to infinity, we're done. So we only need to show an underestimate for the sum of the acute angles tends to infinity as n tends to infinity, and we're done. So what underestimate are we going to use? This is the underestimate we're going to try and do. So we're going to sum up angles of theta like this. So why have we picked these? Well, these theta we can define very easily by theta 1 being the angle on the second dot across the top, theta 2 being the angle on the third dot across the top, theta 3 being the angle on the fourth dot across the top, etc. And the other great thing about these is that they're always the same for bigger n. So if we had a 4x4 grid and a 9x9 grid, theta 1, theta 2, theta 3 would be exactly the same on a 4x4 grid and a 9x9 grid. So if we can show that theta 1 plus theta 2 plus theta 3, essentially the sum of theta I from I equals 1 to infinity tends to infinity, we're done, because we've shown something that's smaller than the sum of all the acute angles for n tends to infinity as n tends to infinity, so we're done. So let's try and find a relation between these thetas. So theta 1 is simply the angle here on a 1 by 1 right angle triangle. We could quite easily work out what theta 1 is, but there's not really any point. It won't really help us tell if our series diverges or converges. So theta 2 is this angle here. So we've drawn this bigger triangle 2 by 2 here, which is essentially this scaled up by a factor of 2. So we have this. Now if we draw this red line here, it's halfway along this line here. So we have theta 2 and we have 1 either side, like this. And so we know theta 2 results from bisecting this angle here, but we know this angle is theta 1, so theta 2 is theta 1 over 2. What about theta 3? So we've got 1, 2, 3, 1, 2, 3. So we've got a copy of this, but with side length 3. And we draw this line 2 up here. And this is theta 3, so we have 2 here and 1 here. And you'll notice now that this is a trisection of this angle here. So we get theta 1 over 3 for theta 3. And this pattern will continue if we had a large grid, if we had n equals 5, n equals 6, etc. So what we're going to do now, we're going to look at the sum of theta i's from I equals 1 to n minus 1. So this is the sum of theta i's for an n by n grid. Because remember, we've got 3 angles for a 4x4 grid, so we're going to have n minus 1 angles for an n by n grid. So if we sum these up, what do we get? Well, we get theta 1 over 2, theta 1 over 3. So theta 1, lots of the sum from I equals 1 to n minus 1 of 1 over I. So we just factor the theta 1 out. Now we know that this sum diverges as n tends to infinity. And this is why we didn't really care what theta 1 was, because we know theta 1's bigger than 0. So a number that's bigger than 0 times something that diverges, this thing is going to diverge. So we've come up with some underestimate of, well, actually a very big underestimate, because it's substantially smaller than the actual sum of angles. But nonetheless, we've come up with some term that's less than the thing we're looking for all n, and it diverges. So that means the sum of all acute angles is certainly going to diverge to infinity, because it's bigger than something that goes to infinity anyway. So we're done. We've shown rigorously that the sum of acute angles as n tends to infinity diverges to infinity, even though we don't actually know the exact value of the sum for any given n, but we've shown it goes to infinity, so we're done.